Welcome to another video on electromagnetic field theory. I've already solved the first two questions of quiz 1, group A. Now I left with the last question, so I'll be solving that question shortly. So without wasting any time, I'm going to go straight to question 3, which is the last question of quiz 1. So we move to question 3. Now looking at question 3, so we have question 3a. Find the gradient of the scalar function w equals to 10r sine theta cos phi. We have to find the gradient. So when it comes to finding the gradient, or when it comes to calculating the gradient of a given function, what that simply means that we are to apply del operator on that function, right? So we have question 3. We know our del operator on the function, which is what? W. Now that we've done this, the next step is now to look at the coordinates, or to look at the variables of what the function that we are given. So we have W. If you look at the variables that we have, you can see we have R, we have theta, and then phi. So R, theta, and then phi, these are coordinates or coordinate variables of what? Spherical coordinate system. These are variables of what? Spherical coordinate system. So that means our function is being expressed using the variables of spherical coordinate system. That means the del operator that we are going to be using, it also has to be what? Expressed in spherical coordinate system. So if we have our del operator, which is here, that means first I write it in spherical coordinate system, meaning we are going to have divided by the partial derivatives of the length of the spherical coordinate system. So we have here it's a vector, right? So the del operator is a vector. Then the next one is going to be partial derivative r theta, right? Then we have unit vector along the direction of the angle of elevation plus r sine theta, then the phi. Then we bring the unit vector in the direction of the angle of rotation. So this becomes our del operator on the function w. So we'll bring our function here. Once we have done this, you can see that we can, just like you are having a number outside of a bracket and you want to simplify, you multiply the what? The number by the what? The brackets. So the elements or this and the figures which are in the bracket. So here we end up getting the r plus this r theta. Then we have the function. Then we have the last one, r sine theta, w. Then we have a unit vector, the direction of the angle of rotation. So we have this. Now, is this the next step? Just mathematics. We are differentiating with respect to r. So we have our function. So we can do it this way. R, we bring our function, which is 10r sine theta, right? Then cos phi. So let me be sure. Let me look at it. Make sure that's it. So yeah, it's 10r sine theta cos phi. So we have 10r sine theta cos phi. So we write our this in here. And then the unit vector we do the same thing. We are just replacing r, differentiate with respect to theta. Then we have again 10r sine theta cos phi. Then we bring the unit vector. Then the last one we differentiate. So we have r sine theta. Then we bring our 10r sine theta cos phi. Then we bring the unit vector. Then we have here we differentiate with respect to phi. So this become, now that we've done this, we can look at it and just do the differentiating straightforward. So we have 10, you are differentiating with respect to r, so this is going to be 10 sine phi cos 10 sine theta rather. Fine. Oops. That's fine. Then along there, so we get, now we do the same thing for the next one. We have 1 over r. Then we differentiate with respect to theta. So you can see our sine theta. When we differentiate, we get what? Meaning 10r. Sine theta, you get cos theta, right? So here we cos theta now. The other ones will be constant, so cos phi. Then we have plus 1 over r sine theta. Into bracket, we differentiate with respect to phi. So we have cos phi, you differentiate cos phi, you get minus sine phi. So we have minus 10r sine theta sine phi here. So I have my, okay. Now that we've done this, we just simplify. So r here will cancel. We have sine theta will cancel. R here will also cancel. R will cancel. Now the simplified version will just 10 sine theta cos phi along the direction of the radius of the sphere plus 10 cos theta cos phi. Then the last one plus, so you can see here we have minus. So it will just be minus 10 sine phi along the direction. So we have this as our final answer for the gradient. So now let's go to the next one, which is, this was question 3a, right? So let's go to question 3b. We have B, 3b. Now with question 3b, you are to determine the Laplacian of the scalar function v, which is equals to s raised to the power 3 y z squared plus s y squared z at point A, and the coordinates are 1, -2, 5. So let's get first the function. We are to get the Laplacian. So when we talk about Laplacian of a function, what that means, it simply means we are going to find the divergence of the gradient of the function. So first you get the gradient, then you take the divergence of the gradient. That is what we refer to as Laplacian. So we write it this way. Now we look at what f. the function v. You can see function v here is expressed in using the variables of Cartesian coordinate system. So that means we have to use the right Dale operators. So when the formula here is going to become the second derivative with respect to the different lengths of the Cartesian coordinate system. Then we have v here, second derivatives. V plus the last one. Let's see. And v. So this is how we get it. So we can get the first derivative. Then after that, we do the second. So the first one, this time we're doing it straightforward. All right. So we do the first derivative. If we look at our function, if we have v is equals to, okay, let me write v. Let's try and write v. V here is what? Write v here. V is, I think S raised to the power 3. Can't get it right. I'm trying to get the function v right, which is x raised to the power 3 y z squared. X raised to the power 3 y z squared plus, let's get the function, plus x y squared z plus x y squared z x y squared z. So this is our function v. Now, based on the formula I wrote, it's going to take the second derivative of what the function. So taking the first one, we differentiate with respect to s. So here will be what? 3 x squared y z squared. Then plus y squared z. That's for the first derivative. We do the same for the next one. We differentiate with respect to y. So we differentiate, that would just be s raised to the power 3 z square plus 2sy z. Then the next one, which is going to be, we differentiate with respect to z's. So here we have, this is going to a 2s raised to the power 3. Then we have z here plus x y squared. Now let's look at we now do the last derivative with respect to s. Let's have with respect to s. This will become x y z squared plus, here there's no s there, so we get 0. Now moving to with the next one, we differentiate with respect to y. So you can see here I don't have y, so this just be what? 0. So we have here to what? 2s z. Then the last one, we differentiate with respect to z. So you can see you have 2 raised to the power 3 y. Then here the next one, there's no z there. We differentiate with respect to z, we get 0. So this is what the Laplacian of this function. And we have to find the Laplacian of this function at point, the point, which let's look at the point. Yes, you have to find at point A. And point A we have 1 minus 2, 5. So point A, 1 minus 2, 5. So what that means that we just replace the what? The variables. That means this one we are going to get. We do replacement 6. S is 1 times Y, which is minus 2. Z is 5. So we have 5 square here, plus 2. We have S, which is 1. Then Z, which is 5. Then the last one, we have 2. We have 1 raised to the power 3. Then the last one is Y, which is minus 2. So let's do this. Now, the first one, we are just having 6, right? 6 times 1, 6. 6 times minus 2, that would be what? Minus 12. So minus 12 times 5 square, that will give us minus 300. Then we have the next one, 2 times 1, which is 2 times 5, that will be 10. Then we have here to be 2 times 1, right? That's just 1. 2 times 1 will be 2. Here will be minus 4. So you can see here we get minus 284, right? So we get minus 284 as the divergence. So we've come to the end of this question 2 as well. See you in the next video. Bye-bye.